All right, welcome to the after work video. It's going to be about 5 to 6 every day. I got a bit of a late start, but let's keep working on this exam because I do still plan to take it against my better judgment. I just think it will kind of keep me sharp and help with my career, and I think that's going to be really important, especially going forward with the next few decades, impact to the economy, all that sort of thing. I want to make sure I'm really sharp and employable. And for my field, that depends mostly on your skills and expertise in the field of network engineering. So let's work on that. Okay, so we've got, so this is where we stopped last time. We got all the configuration working. So let's do the verification steps. So first, let's just check the last one because that's where I stopped. I don't know if I was able to get the commit to go through. We will have a different prompt now. It won't just log in right to where I was last time. Yep, because of that cron job goes off. Perfect. That's exactly right, though. Okay, now we'll put this there. Okay, so yep, everything looks good. Let's do the verification steps. Now, this is how I used to do my studying for 961. I went through all of my notes here and I preloaded everything with these sorts of examples, and then I would do the example, mark it complete, and moved on. And then I would downvote the documentation if it had errors in it, anything like that. So I've moved on from doing that. I'm doing pretty much a whole different way of studying, but I think that way was actually pretty useful. So right now I'm pretty much doing that old way, but I think that is going to be a good way of doing things. So let's see a show route protocol ISIS. Oops, so we've got a problem here. We don't have the same output in the verification step, but that's not necessarily a bad thing because this is essentially exactly what I'll be facing on the exam. So let's figure out how to resolve it. Now, hopefully it's not the bug where it doesn't save my previous commit. Well, I have a feeling it might be. Okay, I'll open these all individually because they're not all opening. Oh. Oops, so it looks like we've got a neighborship through OSPF that is still inactive. Sorry, not through OSPF, through BGP. So let's take a look at that. And it's to neighbor 02. I believe that's this one. Okay, so one thing I can see that's kind of interesting is there's no local route showing up for the route on the loopback interface. I wonder if that's because the local route, because the direct route, yeah, if I were to do direct, yeah, I think for a /32, you don't get a local route, you only get a direct route. So let's do the classic first step for troubleshooting a BGP neighborship that's not coming up. Let's ping it. Okay, so we've got no route to host. So I think the problem might be that ISIS, the configuration on router 2, does not have interface LO00 included in that configuration. So let's check that. Control show configuration protocols ISIS. Yep, and exactly right. So I'm developing a really good intuition for that. I'm really happy that I was able to just look at the problem briefly and tell exactly what was the issue. But it was actually pretty obvious because you can see I did not have a ISIS route for that one where I did for the other one. So it's just kind of a glaring omission there. So, but I'm happy that I was able to get that because this is the exact kind of thing I will need to troubleshoot during the test. And now there we go. It's not such a glaring omission anymore. Okay, so let's take a look at that BGP neighborship. Okay, now the BGP neighborship is up. ISIS looks good. We've only got level 2 adjacencies. BGP is good. Okay, so BGP is in fact not running. Didn't have that set up in the topology or the given commands. All right, so let's try this again. Maybe that's the only issue. So hopefully. Oh, so this is interesting. So the verification step on router D is show protocol ISIS. Well, which one is router D? Oh, okay. So I thought router D was this one. They want to do the verification protocol over here. So in the topology we're using, that's going to be router 4. Okay, so hopefully this looks a lot better. Here we go. So, okay, so here's the key networks. And yep, they've got that special metric, 73. So that's going to be 10 plus the metric that we assigned it in the policy. Let's take a look at that metric. Oh, and the metric was actually on router 3. Yep, so metric 63, It's going to get 10 more. Okay, but yeah, everything matches. So the meaning is, as expected, the 10.2 and the 10.3/16 routes are in device D's routing table as ISIS external routes with a metric of 73. If device C had not added 63 to the metric, device D would have a metric 10 for these routes. All right, so let's cross it out. Oops, and actually I think this is the, yeah, this is the third video. So, and all we really did is compared my configurations to what the configurations actually are meant to be in the second video. Third video, looks like we finished this. There's also and it looks like there's more examples that I think will be pretty valuable. So I actually would like to go through the rest of these examples. It's going to take a few videos, but I definitely have spent quite a few videos in the past. I've given 9-10 topics, videos to a topic in the past, and I think it might be worth it in this case because these examples look like they're pretty valuable. All right, format, text, strike through. All right, so let's look at the next one. And it might even just be right here in the same document. Well, maybe not. So redistributing OSPF routes into BGP. Oh, okay. I think this is it. So this is injecting. So it's a bit of a different term than redistributing, but I think it means the same thing. Yeah, so it's going to mean the same thing. So let's do that. Okay, so this is going to be, I believe, yep, it's going to be an export policy. We're just the same thing we did here. So this is just going to be an equivalent policy to the policy on router 3, which is injecting ISIS routes into BGP. So we can see, I'll make this a bit easier to read. We can see on router 3, we've got a term send ISIS and direct, and then from protocol ISIS. And when we are actually filtering those routes down, but the difference between this policy and the policy in this other example here is the policy in the example will not have a route filter to it. So let's take a look at it a bit more carefully. So here's the step-by-step. So that means this is just everything that's going to be there. So we're going to do, yep, so from OSPF, anything from area 1
then we would accept, and then we're just gonna export that into the BGP config. So real easy stuff. Same thing for ISIS. I don't think it's worth diving into deeply because it's really simple. You just create the policy statement name, you create the term, and then you will what you want to match, and then as long as you've got then accept, you're all good to go and import it, or sorry, export it into your BGP. And these, yeah. So yeah, if you go back to my 961 series, I started with a really strong confusion over the term import and export, and I definitely got that confusion worked out. I think, you know, just to try to say how I worked it out without a long explanation is kind of what I'm trying to do now. I think I can do that by saying that we're talking about the routing table as the perspective. So if you make a policy to apply things going into the routing table, that's an import. But if you make a policy to apply to things leaving the routing table, as we are here, where we're talking about ISIS routes, direct routes in the routing table being sent out of the routing table, out from this device through eBGP, or it would even be the same for iBGP, as long as it's as long as it's being sent out from the device, it's an export. If it's for it coming into the routing table, then it's an import. Import policies are actually pretty rare, so generally a export policy is going to be used more often than an import policy.
Import policies basically are just, let's say that I'm learning a ISIS route and it has assigned to it a metric of 63, but you don't want that. You can set up a import policy to give it a different metric, that sort of thing. All right, so let's, yep, so let's mark this complete because it's really not any different from the one we just did. All right. So the next one is exporting direct routes into ISIS. So this is you know, one of the big reasons for my confusion. You wouldn't export it into something. Like exporting, well, you kind of would, but you can see how confusing it is to have the word export and the word into. Like a better, yeah, well, I mean, it makes sense, but it's definitely something I needed to learn, but I think I did a good job of it in 961. Okay, so exporting direct routes into ISIS. Okay, so I think this is going to be similar to the other one. In fact, we already did that here because, as you can see, we are matching for direct routes as well, and then accepting them, and then exporting them. We are exporting them into eBGP, not ISIS, but I do not think there would be really any difference. let's just verify that that export statement is available for protocol ISIS. Yep, so you can export just like you could before. And in fact, that is how we changed the metric on those routes. We used an export policy and applied it to ISIS. Another thing you could do, which is a little bit, yeah, this is a little bit strange of a series of words, because this almost seems like something you would do for BGP. So it almost seems like they're saying exporting direct routes into BGP as if they were here, because you can see. So it's kind of a strange combination of words for me at this point. Like you wouldn't export a route into an IGP. I thought like here, let me explain. So on router 3, if I do show pipe display set type no more, we've got these interfaces added here. But of course, we know each of these interfaces they have, oops, let me do a show route, run show route protocol direct. So they have direct routes on each of them. So you don't need to export a direct route into ISIS. You need to do it for BGP. But for ISIS, that happens automatically when you add the interface to ISIS. So the way you would do this is by adding the interfaces to the protocol configuration. You wouldn't do that through a policy that I know of. So this is kind of, it's kind of like if I've been learning the whole time that, you know, cows have 4 legs, and, you know, animals have 4 legs. Well, now I'm seeing an animal with 5 legs, and it's like, well, that doesn't make sense. Why are they saying to export direct routes into ISIS? That does not seem consistent with the behavior of an IGP. But okay. So I'm really curious about that, actually, because like I know why you would redistribute routes from a different IGP into ISIS, because they were learned from a different area, and you would need to, they would not be, so let me do again, show pipe display set. They would not be added to ISIS simply by adding a statement under show protocols ISIS the same way that direct routes would. So let me do a run show route protocol ISIS. So okay, so you can see we don't have any, and we don't have these in here, but that's because the they're directly connected. They have a lower administrative distance here than these do. These have 18, these have 8, so we're not going to have those in here. So I'm wondering if this is for having your own direct routes show up as ISIS routes. I don't see why you would want to do that. So I think I'm just going to kind of not let myself get confused. I really don't see what the point of that is. It could even be a typo. They meant to put BGP. So I guess I'll do a few more Google searches. Oh, Explorer, I don't like that. Okay, let's see if there's anything about direct routes. Nope. Yeah, so that's really not something I would ever think that you would want to do for IS, because if you have a direct route on your device, I don't see a reason why you would not want it to be a direct route with this lower administrative distance, and would instead want to create a special policy so that it showed up as an ISIS route. That really doesn't make sense to me at all. And then on other devices, if I do a show route, for example, on this, and I can pick any device in my topology, the ones in the, I'll have to pick one in the same AS to see it as a ISIS route. But you can see they do show up, and they are ISIS routes, but that's not because I set up a routing policy. It's because I added the interfaces to the protocol's ISIS hierarchy. So just for kind of for fun, let's take a look at what that route looks like on router 5, which is the other side of that eBGP connection. So okay, so it's a BGP route, which makes sense because it was, and the other thing we can tell is it's eBGP because it has a AS path. If we were to look at some BGP routes on router 1, oops, so the only ones we've got are here. And we did learn these through IABGP, but they were, let's take a look at router 3 again. Oops. So okay, so they were actually learned let's see here. So I mean, obviously they were learned through BGP, but I just want to see how they were sent. Okay, so I think it just automatically, if it learns it through eBGP, it automatically sends it through IBGP. Because I'm just a little bit surprised that these were not learned through ISIS. But I think I'm surprised that one, they weren't learned through ISIS because we're redistributing. Yeah. Oh, okay. Well, yeah, I guess that's not too surprising. The other thing I was surprised by is not seeing an export policy under IBGP. It was just kind of unclear to me how these propagated all the way through to router 1 as BGP routes. I would have expected them to be ISIS routes, but they are BGP routes, so it's clear that they were propagated using IBGP, unless maybe there's policy on here that converted them, but let's see here. No, I think it just seamlessly goes from BGP, eBGP to IBGP. One thing I am very curious about trying though is I'm going to go deactivate protocols ISIS. And I'm going to see if those routes disappear. Okay, and they do disappear, but they're now hidden routes though, because they're unusable. So they didn't actually disappear. I still got them. Let's do a clear. Yeah, I just want to verify that they actually were actively learned and they're not just like stale addresses, but I'm not sure if I can do that. I thought I could just like clear the routing table or something, but I can clear BGP. Yeah, table. Let's try that. Let's just clear BGP neighbor. Oops, but if I do that, it won't reform because I disabled IGP. Okay, so yeah, that's actually I think good enough evidence, in my opinion, that yeah. So you need the IGP and you need BGP. So I think let's see here. So I've got. Okay, so I've got the ISIS configuration deactivated, but I've still got BGP neighbors, but that's just because the whole time, the dead timer, the whole timer, I'm actually not sure which one it's going to be, but a timer expired. So these are actually now down. So I think the original question I had was, are these being learned over BGP or ISIS? And it is clear that yes, they are being learned over BGP. It's marked that way in the table. But what I was curious about is, since they are learned through BGP, can I just disable ISIS and still learn the routes? That's the question. And the answer to that is hopefully an obvious no, because in order to have that route, you need an IGP in order to form a neighborship, you have to have that IGP functioning. So I could not learn the routes through BGP without my IGP. And the reason is is because in order to establish my BGP neighborship, I need the routing information I get from my IGP. So you can think of it like two different ways. You've got, in order to have a hot dog, you've got to have a bun and you've got to have the actual hot dog itself. Otherwise, you just have, well, I guess if you only had the hot dog, you'd still have a hot dog. But I guess it doesn't need a fancy analogy. It's just that without that IGP, you don't have enough information to form a neighborship with your BGP neighbor. Okay, so we can activate this and we'll see those neighborships come back up. Might take a little bit. And then we'll see the routing table look better.
Here we go. We got the elusive open confirm, which is always nice. Kind of surprised the other one's taking so much longer. Huh. The other one's just not coming back up at all, even though all I did was activate and deactivate. Yeah, still not coming up. That's interesting. I believe it was fine before. Now it came up. Okay, so let's take a look at the hidden table. So nothing in there, and that's because they're in the regular table now. Okay, so I'm definitely gonna mark this one off. Really not sure what they're getting at. I think I've got a good enough concept of exporting anyways. Okay. So one thing I don't think I have a great concept of though is exporting internal ISIS level routes into level 2. Even the whole concept of what is a level 2 and what is a level 1, I'm definitely not super clear on. So let's work on that. Okay, so here we go. This is from a level 2 to a level 1. I wish I could get one from a level 1 to a level 2. Here we go. All right, so let's see what we got here. From a level 2 to a level 1, yeah, thanks. I mean, maybe it's. Oh, okay, here we go. So here's the. Okay, so this is going to be the documentation for the next one, but I need one for level 1 to level 2. So let's just do, this is the ISIS user guide. So let's go to the main level, expand all, and go level. So this is leaking from a level 2 to a level 1. There we go, we've already found that one. But we don't know how to leak a level 1 to a level 2. Which is that something that's even like something that is desirable? Let's go back to the main, expand all, and go leak. Okay, so hopefully there's an explanation for what leaking is. This example shows how to leak prefixes in an ISIS network from level 2 area, a level 2 area to a level 1 area. Every routing protocol passes routing information up or down the routing hierarchy. This bidirectional flow of routing information is known as route leaking. By default, ISIS protocol leaks routing information from a level 1 area to a level 2 area. Oh, okay, so that's why. This is the default. You don't have to have an example and put configuration for that. That's just the default. All right, so yeah, let's do this one now. However, to leak routing information from a level 2 area to a level 1 area, an export policy must be explicitly configured. And that's interesting to know because level 2 area, that's going to be like your equivalent to the backbone areas. So the fact that you've got a leak in order to populate your multi-areas with information, that's quite a bit different from OSPF, where it'll happen automatically through those summary LSAs by your ABRs. Whole different process in ISIS, and in fact, there's a lot more manual intervention required, it seems like.
All right, so here's the topology. So yep, let's set up this topology and just do the whole example. Okay, and hopefully I can make it less. I can do it a bit smoother this time. It wasn't so smooth last time. All right, so for some reason it starts at router 3, but that could get confusing really fast. I mean, I could change the host names, but I think I'll just decrement the numbers in my mind by 2. So router 3 is router 1, and router 5 is router 3, but it's definitely not an ideal way to do it. Okay, and then we've got level 1 over here with these 3 routers, and level 2 over here with these 2 routers. We've also got router 6, but it's going to be decremented by 2 in my lab, so it's going to be router 4. And then they've got router 7, which will be router 5. Okay, so now we're going to need to wire them up. And for this, I can pretty much do it the way, however I would like to. So I think I would like to do it where these are connected. Yeah, so 0 goes to, yeah, I'd like to do it 0 goes to 0 here, and then 1 goes to 0. Okay, and then 1 goes to 1. All right, and then 2 goes to 1. 3 goes to 1. All right, and then 0 to 0. All right, and we've got better information here. We've got the IPs or the masks that these are all going to come out of. We've got the area here. Now, one thing that I found instantly interesting is that it starts with area 1. So perhaps it's not like OSPF where you need an area 0, but we will figure that out. And then, of course, we've got level 1 here. We did get loopbacks in this one too. This is going to be better.
So let's do the same thing we did in the last video, where I just try to do it however I think it needs to be done. And then the next video will be the answer key, where I just go through and grade my work. So
in this video, I'll just clear off the devices so that they're ready to go. And then I'll see you in the lunchtime video tomorrow, where I see if I can come up with the right answer. So let me write that down. So next video, config this example using only what I already know. Then in the next video after that one, I will grade my work. I will look at the answer key and grade myself. Okay, so yep. So the last thing I will do in this video is clear all of these out so they're ready to go for the lunchtime video tomorrow. Okay, so all we're going to need are these statements here. So just 4 statements. And I could, of course, change the host names to match the lab. I don't think I'm going to do that. it wouldn't even change the tab name. It would just change what I'm seeing here. So I don't even think it would clear up confusion really if I changed it. Oops, so delete, yes. And now I will add back in these commands. Commit and quit. Show pipe. Oops, show configuration, pipe display set, pipe no more. All right, so got 4 more routers left. Okay, so everything, as far as I know, unless there were mistakes, but we'll find that out in the next video. But everything looks like it's good to go. So next video, I'll be trying to configure this example using only what I already know, not looking at the configuration that's given. And the video after that one, the after work video, I will be seeing how well I do. So thanks for watching, and I'll see you in those next videos.